So we are good to go. If you want to continue, you can start.
Okay, so do we need some introduction? I mean, from Networkings. I mean, someone from Networkings hosting there, or shall I take it as a host?
You can take it as a host. So I have made you the host. So Gaurav here. So I have already made you the host, and you can start.
Thank you very much, Gaurav. Thanks.
Thank you.
So, guys, good morning, and just I wanted to know what is the batch strength we have here? How many students are expected to join?
This is actually the first introductory demo session, sir. So you can, like as of now, there will be students who will be joining in, but this is actually the complete introductory session of for the CCNA first class.
Okay, that's completely fine. Thanks for the brief. Yep, guys. So let me introduce myself. I'm Madhav, and I have been working in industry since since 2003, and almost I'm completing my 20 years. So, guys, there is a lot of adventure here, and you will see a lot of things which will be new, and there will be freshers, there will be working professionals with us. So we will be looking forward that what you guys are carrying, and then we will go step by step. So just a quick brief about my career. I started as a network engineer, and 10 years I have worked as a network engineer. Further, I started working in data center. So I was working in data center as a network engineer. Post that, I started to work on various cloud technologies. So again, 3-4 years I worked on cloud technologies, and then I switched to software. So I had a various technologies wherein I touched and worked on, and I'll give you my industry experience plus my technical skills. So guys, this is what I carry forward to you. Rest, I would like to hear something from you guys that I would like to know my audience, that what kind of audience we are having. So are we having freshers or we are having working professionals as well? How many of you are freshers? And first of all, how many of you are freshers? And you can just raise your hand in the, this Zoom session. So from participants, okay. Salim, Fahad, okay. You two are fresher, great. And rest, I expect they are working professionals, right? Great, no worries. So happy to see that. I will be sharing my screen and just confirm once you see that. Guys, can you see my screen? Just raise your hand or write in the chat box. Perfect. Thanks for the participation. So thank you very much for confirmation. Hope you all can see my screen. So we are going to start today CCNA. That's a very common term. Everyone nowadays knows what CCNA is. Maybe a decade back, it was a kind of a big term. Very only few people knew, but now most of people after graduating or after completing engineering, they know CCNA. People from technical background as well as non-technical background, they take this course. And nowadays, there is no such rigid parameter in the MNCs that they hire only guys from the engineering background. What I have seen now, the trend is changing now. Even those who are from another background, they have been given opportunity into the organization. Only thing they need some technical skills. So guys, what technical skills we can equip with? One of them is CCNA. This is a starting level certification, which any networking guy or anyone who want to start his career into networking can have this. So this is offered by Cisco. We all know Cisco is one of the very common name. Any networking equipment you go, Cisco is the vendor which provides any networking equipment. Generally, it is famous for router and switches. So Cisco is one of the biggest brand that provides all kind of networking devices. There are other vendors also in the market like Juniper, a lot of other things, but the same company Cisco, they give certification. Certification, I mean, means they examine you on certain parameters. They have a set of syllabus wherein they examine you. They have an exam code, they have a time, and they have certain amount of fees attached to that. So you can see in the box here, exam discrimination, the exam code they give is 2 not 3 not 1, and this is a 120-minute examination, and it costs around 300 USD plus tax. So this is what CCNA is. So once you have this certification, you can attach this in your resume, and that makes a plus point in your resume, and that makes you one step ahead of other competitors in the market. So now we are familiar with what CCNA is. Going forward, we will see what kind of exam structure they are giving us. So guys, CCNA exam course, this is generally, if you understand the terms, you can complete that in 1 month, the syllabus and everything. But in a generic way, if you go for understanding and technical skills you want to acquire for the examination, which make you completely fit, so that's around 1.5 years. So wherein you work somewhere and take experience and prepare for exam, and then you give, so you have a great foundation. So what are the topics that they going to take on this, or what are the things which they test us? There are around 6 parameters which they are going to cover in the examination. Why I am taking this? Because we are setting our goal. Once we start our curriculum, before that I want to set our goal, that what is our goal, what is the target, what we want to achieve. So this is the set of targets which I'm defining. So we took CCNA, so we are looking the various components, the exam structure, and further we will see how we are going to start. We'll start the syllabus. So we'll see how exam pattern is, because guys, uh, one thing, knowledge is important. I do agree that we do have knowledge, but at a time we should have how to present it. That's also more important. And to present our knowledge, we should have some proof. So certification is one of the important thing which we can write. There comes a number, certification number, which you can write in your resume, and that could be verified globally. So that certificate number gives us a unique identification among a lot of other competitors. So that's why I'm putting a focus that just having knowledge is good, but parallelly, if we can complete the certification, that's the very plus point. Definitely on the basis of knowledge, we can bargain the job. But once you have a certification number, that makes a big difference. So when it comes to clearing the exam, there are a lot of things that has to be taken into consideration. I know that there are jargon in the market that we can get the certification in certain by paying certain amount of money. But the adventure is when you clear it by yourself, by studying yourself. Uh, you not take any proxy examination. Proxy means someone giving on our behalf. So if we do it ourselves, we can become architect one day. And we all know architect means the master, and they get a very green, green carpet, red carpet, whatever you say. They are very highly paid professionals. So in order to reach there, to become expert CCIE, before we reach the expert level, we start from the foundation. So CCNA is a foundation. And when we talk on the exam level, there are very increasingly we have to go topic by topic plus practically. So we will focus on both the things. We will see practical aspect. So those who just want to start their career as a network engineer, they can just go through that with the knowledge. Or those who want to crack the exam as well as they want to start the career, both they want. So they can pursue both. So we are taking both ways. So guys, let's start with our curriculum. So here, these are the 5 topics which Cisco tests you. So what are those? Number one, that is network fundamentals. Second one is network access. Third one is IP connectivity. Fourth is IP services, then security fundamentals, and finally, automation and programmability. Now we will see how they are giving the weightage on each and every section. Folks, this is the weightage, what they provide on each and every section. So what we see here is 20% they give on network fundamentals, 20% weightage. I means these are the basic questions which come out of this. Means 20%, around 20% question. There is no strict rule out of that, but because Cisco has a right that they can change their pattern anytime. But this is a rough idea through which they assign questions and answers or whatever question they ask. So this is the basic parameter. So 20% network fundamentals, 20% network access, 25% they ask about network connectivity, then 10% they ask from the IP services, 15% they ask questions from security fundamentals, 10% they go with the automation and programmability. So we will see now roughly how network fundamentals are there, what are those network access things, how IP and connectivity works, how IP services works, how security is provided to all these, So we'll see step by step how these all terms correlate each other. This looks different, but they all correlate each other at certain point. So we will see them one by one. But before going into, more like a schoolboy or curriculum way, I want to take it more in a practical way. And I want to give you a proper exposure wherein, if you land up in industry or you are already in industry, you can relate it more clearly. So let's start with a basic layman language. Layman language means, I say, like wherein, every day, nowadays, every one of us are using a mobile. Most of us have. If we are in networking, definitely we are having laptop, or anyone working in IT or non-IT also nowadays, laptop is a very common commodity that everyone has. So just starting from the basic home networking setup, wherein we can correlate what exactly networking is. Generally, we are using networking into our day-to-day life. So we will see those terminology one by one. So folks, on your screen, here is a basic home network. In this, you can see a cloud, ISP, and you can see wireless devices. And you can see a few computers at the right-hand side. So this is a general home network. Most of us take connection from service provider. The service provider, maybe there are a lot of service providers nowadays in the market, but two are the prominent. Like we all know Jio and Airtel. These two companies provide internet nowadays. Market, most of other small companies has vanished. So in India, these two only the main service provider. So going forward into this, you can see ISP router and modem. So once you dial some, you Google that who is the ISP provider in my area. So there are a lot of, vendors, they come that, okay, Jio, Airtel, or BSNL, a lot of other vendors comes. So you dial in them, they come to your home, they install a router. And after installation, they start the internet and they say, sir, your internet is working, you are good to go with this. So we just start surfing. But now this is a general pattern of, any home that they use internet, or a simple user who's not even installing this router and this all stuff. They just surf in a mobile. So they have internet. Nowadays, everyone has internet. So most of them know that where it comes. Most of them doesn't know, and few people know. Like those who know, we are the people who we know, because we are architecturing this in future. So going further, this is our home setup, wherein we just install router. A router We all know what router does. We'll see all these terminology one by one coming slides, wherein what router does, what switch does, what are these endpoints. So we will see each of these topics in detail. But this was just an exposure to you guys, wherein you can, understand how a simple network works. So simple network consists of one router, an ISP, and few endpoints. So this is a general setup. Now we will see more in detail that how this has been leveraged and how business has been done out of this. Like suppose I want to earn dollars and money out of this business. So how I make that? So let's go and see how that has been done in the market. Guys, another big thing coming in 2025, coming 2025 and 2030 is data centers. This is the big boom market nowadays coming. So now coming to the point, how all of a sudden this term data center come into the picture, and from where CCNA is getting connected with this data center. Yes, this all starts with the data center because this is the place where all our data stored. Like we are using mobile or laptop, we are watching YouTube videos, or we are accessing some site. So those sites, those data, they must be sitting somewhere. So where this data is sitting, so these data are sitting into these data centers, in these racks and servers. We will see all these terminologies in coming days, that what are these racks, what are these servers, and in coming slides also things will become more clear. So this is the place wherein your data is sitting. We are sitting in our home and data is sitting here. So the name itself says data center, means all data are stored. You can see there are slots, there are wires, there are few devices inside that. Those devices are called servers. So servers can be of HP, Dell, there can be a lot of servers. And then there are wiring, you can see racks. So herein we store data, and there are various technologies through which those things are achieved. We will see them in the coming slide, wherein we will see how these things are correlated. Going further, yes. Now here comes the story that you see this is data center. This is the front view. This looks very good. I mean, very glamorous. But what's beneath this? How this wiring are arranged? How these devices are connected? That comes the question, that how these things are working. So to answer those, we will see. And then again, I used a term that if you want to make it, we want to make a business. Business in the sense, suppose I want to earn, I'm storing data, but I can also make a small data center or mid-sized data center or small-sized data center, tier 1 data center, tier 2, tier 3. These are the terminology given to the data centers according to their, like we have hotels like 5-star hotel, 4-star hotel. Likewise, we have data center certification there called 2-tier data center, 3-tier data center. So according to their facilities and their privileges, they given the tiers. So this is how, and according to that, their charges are there. Suppose you want to host your server, so you can host it here and make some money out of that. So this is how we can make money. Now, if we are going to start our career, so there are various scopes which comes here. I bring this point here because what we are studying, we must know how to use that. I know a lot of things, but I don't know how to use those things. Doesn't make a good bargain. So the point is that suppose I know something, okay, we do certification. That's one advantage of that. Okay, we are getting certified. That's advantage number one. Next point comes, we are going to get jobs. That's advantage two. But wherein we are going to get jobs? So these are the places wherein we will go in future. As a network engineer, these are the most wanted places. These are the places we are required. So either we will apply in the data center, we will get job in data center, or we will go in a ISPs. So these are the two most wanted places wherein people go. And as soon as you land up as a network engineer, definitely you have to deal with this data center, because as soon as requests will come, then you have to say, okay, this request is coming from data center 1. This request is coming from Airtel data center. this request is coming from Reliance data center, you will hear the terms like my router is sitting in data center 1, this second router is sitting in data center 2. So these all things will come at that time. That's why I'm bringing this, because when you will start your career, these are the places, these are the things which you will see the most. So now we will see that how we work as a network engineer into these places, and what our roles could be, and how we can fit in into this. So going forward, what we see, this is the architecture, data center architecture. This is data center, and this is how the background they are designed. So they have a blueprint, they have a high level design, they have a low level design. So high level, low level doesn't mean the way the term it sounds. High level design, they are network designs wherein they depict how things are arranged, things in the sense how networking devices, servers, and their topologies, how they correlate each other, how they reside. So that's high level design. And when you break it down to a very minute level, to very small details you depict, then it comes as a low level design, wherein you tell them how firewall rules are there, how each and every router is working, how servers are residing behind that. So that's a low level design. So this is a basic simple diagram wherein shows how our data center is architectured, and we can work like when we start our career in networking. We start as a service desk engineer or service desk network engineer or network engineer as we start as an associate. So you can see here there are servers and there are Tor switches. We can see here in the left hand side figure I'm pointing, wherein you can see there are three kind of switches which you can see: core switches, aggregate switches, and Tor switches. Just to make things little clear, so that although you guys know what router and switches means, we will see them in detail in coming slides, but just to give an overview, uh, routers are the device which connects you from the outside world, or which connects two different networks. So that's the router. So suppose I want to come from outside, like just we saw in the previous slide that you get an internet service provider and then they put a router. So that's how with the router, your home devices are getting access to the outside world, to the YouTube or whatever websites. So here, same thing here, we are bringing the same concept. So here, router also connects all these devices to the outside world. And now inside means inside the data center. So here when we refer data center, that's our home. We can refer data center as our base location or home. So inside the data center, this is the architecture. So we can see in the right hand side figure, that's a very basic figure, wherein you see on the top, it is to internet. So from internet, data is coming. R5 is our, router. So it lands there. Further, it goes to the first tier. Therein, there are more routers. So first router is, very fast and very intelligent. Second one is as well like that, but less efficient than the first one. Then there are a lot of wires. In between, you can see 4 wires each router. 2 wires to 2 routers in the left. We have total 4 wires, total 8 wires we can see. So those extra wires are for redundancy. Suppose R1 fails, so R2 takes over. In both the R5 and R6, we can see there are on top, we can see 2 routers, that is R5 and R6. As you come down, there are 4 routers, R1 and R2, R3 and R4. So R1 and R2, they are for redundancy. Redundancy means suppose R1 fails, so R2 can take over. So that's how they are arranged. Further, we can see H1, H2, H3, they are the servers. But again, between R1 and H1, there are a lot of other devices. So coming to the left-hand side, herein you can see these are switches. These are the switches which comes in between. So first comes core switches, then come aggregate switches, and then there are Tor switches. Further, we get our server. So when we enter into the enterprise, when we start as a network engineer, we have to access the Tor switches first. They don't give access directly to the core switches and routers directly. So they start with the Tor ones. They give you read writes, wherein you just see the commands, you see the traffic flowing, you see the various protocols, how they are working. You see various commands, router and switch commands. You access various switches and routers through PuTTY, and many other tools are nowadays available. So you access these all devices through PuTTY, and you see how they are connected with each other, how things are flowing. So we're not going more deep into core switches, aggregate switches. Just understand that core switches are the one who handle all the traffic, and then aggregate switches distribute those, and then Tor switches further, classifies those traffic into the servers. So the traffic flows vice versa, up to down and down to up, upload or download, you can say. So this is a basic architecture. I hope this is clear to everyone. So this is the general architecture of data center. Now, next comes, this is inside data center, and we are sitting on the other end. There are two ends, and one and end two, and one which we see right here. This is end one, wherein we guys are sitting right here. You see computers, mobile. So this is end one, wherein we are sitting, and we are accessing few data, maybe it's Facebook, YouTube, or whatever you call, through our ISP, through our router and modem. So we are at one end, and other end, we are accessing data from where? From here, from data center. This is end two. So there is a communication between 2 points, end one and end two. Is it getting clear? I think things are getting clear. This is end one, and this is end two. Here we are accessing data, and the data is sitting into data center. That's the story. And now, this is basic DC architecture, and then these are the entities which come in between end one and end two. These are the entities which facilitates the traffic, how the data will flow. So these are the traffic management endpoints, and this is how the traffic is managed. So we will see those. Before going into this traffic management, we will go a little bit into the data center architecture. So going a little more detail into data center architecture. See, in our home network, that was pretty simple. That was, we don't have to define a zone or anything like that, because who is going to access our home data? Yeah, definitely nowadays hackers from China, a lot of other countries, they get access to our data, and they spyware and ransomware they put, and they ask for ransom, that okay, you pay this much, then we do. But generally our local systems are very few targeted compared to those of the enterprise, because enterprise do have a more economic value. So suppose there is a bank a server. Suppose we are a bank server is sitting into this data center, and there are Facebook servers sitting in this data center. There are a lot of other enterprise which are sitting into this data center. And suppose people like me just go into that and hack, or people like anyone can do that, especially outside country, only inside country no one does. So, well, they get into this, they can access to all the accounts if there is no security, if there is no proper management for data, they will get access. Everything will be collapsed. Nowadays, everything is digital, your accounts, my accounts, everything. So there is the requirement to management to protect those data, and have a robust system to give and facilitate a proper transparency. So in this slide, we'll see how those things are achieved into the data center and how our data is protected. Suppose whatever data we are accessing, generally we have a Gmail also have a server. So they have our data. We have our licenses like Aadhaar card, licenses, Aadhaar card, all these identity proof, they are all stored in a data center, government data center. So how they are protecting our data? So coming on the basic layman language, that how they have been doing, we saw basic architecture. Coming forward, this is how they are designing the zones inside a data center. On the right hand corner, you can see DMZ zone there. Then there is a trust zone. There are a lot of other zones they make. Generally, there are 3: DMZ, internal and external. But we won't go more detail into the zones, but just for convenience, like we define a zone in our, this is my area, this is a sensitive area. So that's how they define a zone: DMZ zone, internal zone, external zone. So how they do here is, first you can see WAN means this is internet. On the right hand side, left hand side, you can see WAN. From there, internet comes, and there are HSR router. They are very high speed and very high algorithm routers, which segregate the traffic very fast within, and they have very high redundancy and failover. So they are very high end routers. And then there comes firewall. Firewall is to protect, attack against hackers and other malicious people. So here in, any attack to access our data, they are triggered and they are removed. And then again, according to various zones, the traffic is divided. Like we have blade server in the DMZ zone, and there we have other servers into other zones as well. So we can see a lot of servers according to zones they have divided. There are firewalls, there are routers to segregate and make this setup. So not getting much confused, I just wanted to give you a basic overview of how architecture of data center is done. Going forward now, this is internal inside data center. Again, I remind you, this is endpoint B. Endpoint A was our home. This is, again, I'm reminding, this is endpoint B. We are accessing data from here. Now, between these two entities, endpoint 1 and endpoint 2, traffic is there. Whole traffic management lies there. So this traffic of this digital technology and the traffic of this IPs and networkings, we as a network engineer, we manage this traffic. So we can find our job either into data center or into this ISPs. So who manages these traffics? These traffics are managed by ISPs like Airtel and GU or BSNL in India. In other country, they have, like in Singapore, you have Singtel. In US, you have having Verizon, a lot of other service provider according to their country. So we manage this traffic. So we all know, making it more familiar and easier for each of us. We all traveling nowadays. Most of us has traveled in the metro city, or not in even metro city, in general city also. We travel. When we go on our car, on bike or bicycle, whatever. So where comes a point wherein we have to stop, where the 4 ways going, then there is a red signal, green signal. So there's a traffic police there who says, okay, move this side, move that side. This was in small cities. In big cities, they have a lights like red light. We have to stop. Green light, we have to go. So there are which traffic will go which side, decided by these lights. So that's a traffic system in general. Then we have an airplane traffic, like we see airplanes flying above us, but there is a huge management behind that, wherein we sitting inside a plane don't realize that they have a certain route and they have a specific path and they have a specific trajectory that only they follow. We feel that, okay, we are flying. It's very good. We're enjoying that. But pilot knows that which route he has to take. He doesn't move a 10-degree left or right. He goes on the design path what he has. So that's how it works. Like a layman, he just access internet into his mobile. He don't know how the things are flowing. So we also have a traffic engineering here. So this traffic engineering of data and internet, that is called network and network engineer, wherein we fit in. So we will manage this traffic. So we are like a cop who will manage this network and IP traffic. So we are a kind of policeman who manage this IP traffics and internet traffics. So yes, we have to understand that way, that how traffic flows, how things are coming, how data is going, how IPs are flowing, how packets are encapsulated. So we'll see all those, that how things are flowing. So giving you guys a top view that how things flow. like we access internet. So how we access internet? We just open any site, www.google.com or www.youtube.com or whatever. So we access these through laptop or our phones, and those are connected to Wi-Fi, and those Wi-Fi's are connected to internet. Internet is generic term which I'm using now. We all see whenever we travel nowadays, we see on the top of the building there is a tower like this, which you see right here. Again, on somewhere you're traveling on the highway, you see a place wherein surrounded by a fence and there is a big tower lying there. And maybe you can find on nowadays, not here in the sea, but fine. They have a coaxial cable in the sea. So below the land also they have a coaxial cable. Generally in the sea they do have that. So coaxial cable running inside the sea. And above on the air, on the space, you have satellites, and in between we are having these towers. So there are three types of communications which flows. One which goes in the water. You must have heard that someone cut the cable, Chinese people cut the cable in the water, or this country they cut the cable, because there are sea which are passing through various countries. Every country have their jurisdiction over the sea, but they have a certain line of cables, internet cables. They pass from one country to another and they reach to our country. So those cables are managed by us only. So we'll see in coming slides that what are kind of transmission media which we use. And this is underwater. Second comes on the space, like satellite. There are a lot of satellites. Every country have their satellite. So directly there are certain devices like VSATs. VSATs are the devices which directly connect to satellite. So there are remote areas wherein cabling or microwave or this kind of tower communication is not possible. So directly therein they communicate with the satellite. Like militaries use those services. Armies, they have to go in a rough terrain wherein they don't have accessibility of wires all the time, or they can't access to their base stations. So they use satellite phones. You must have heard the term satellite phones. So second is this through space. Third one, which is very commonly used, I mean, everyone know these towers we all see. So this is the third one, wherein each tower gets connected with each other. So now question comes. First, data center is there. Second, we are there. Now these towers are there. That's a kind of web that they are interconnected with each other. We'll see how these towers are interconnected. Most of us our time we'll focusing on these towers because that's what gets connected into any country. In any terrain, these towers are nowadays like 4G, 5G. The towers only. These towers only are 4G and 5G. Technology, of course, on the back end, these are the technologies. But these technologies reside in a device inside this tower only. So now we'll see that how this technology work, how this tower work. First of all, we'll see. Definitely, because networking starts from this tower only. If you understand this tower, it's very easy to understand the data center and very easy to understand what's going in our home. So fine. Now coming to each and every individual tower, that what these towers are, why they look so tall, and sometimes they are residing on a building, or sometimes they are standing on a ground. So they are called ground-based tower or building-based, whatever. So why these are so categorized like that? And what are the frequencies, how they work, basically, how they are connected with internet, and how they manage traffic. So let's go. Like you can see red lights. There are every crossroad you can see red lights. So you correlate that those red lights are here towers. So there are a lot of crossroads wherein there are 4 junctions, 6 junction roads. So therein you have red lights. Especially you have police also there if the traffic is huge. So those red lights you can correlate as towers. These are the crossroads wherein traffic cross. So in terms of networking, these are the places where traffic cross. So we have a red light there. Red light in the sense tower there. Now we'll see what this tower are. On these towers, if you analyze little carefully, you will see few devices. You zoom yourself a little bit, then you will see these devices. Otherwise, we just see tower only, but making our eye more clear. Just sometime when you're traveling or you see a big building and you see a tower on that, just don't go much near, but from distance you can see. Then closely when you will look, you will see these devices. So there are two kind of devices which are hanging on this tower: RF devices and microwave devices. These are the mainly two devices which are residing on these towers. So RF devices, what are these RF devices? RF devices are radio frequency devices. They radiate frequency, certain frequency, which is allotted by the government, and other end, they receive that. So you can see there is a big disk, and then there is a tube-like structure in front of the disk. So there is a transmitter and there is a receiver. So this is antenna wherein they receive the data. Now we will see little detail into this, that how these are connected. So these are RF devices. RF devices for small range. Microwave devices are for the long range. That's the difference. Microwave range is very vast. So when the distance is more, we use microwave. When the distance is less, then we use RF device. So there are a lot of companies, they provide RF device, like Cambium is one of them, Maxset, Cambium. These are the companies. You can Google these RF devices. You will get to know more detail into that. Then there are another kind of device which are hanging on these poles and these towers are microwave devices. So microwave device, they have a certain frequency, and that's how they, you can see the architecture, that there is an antenna on the top, then there is a ODU, outdoor unit, then there is a cable, and there is an indoor unit. So now every tower has a ODU and IDU, outdoor unit and indoor unit. So I started my career as a field engineer into this. So that gives me a big exposure that how exactly things are flowing. So any one of you can start your career here also. That every tower is not independent. There is an engineer assigned to each and every tower. They go regularly, they check, they take the readings, they have a checklist they follow. So every tower, they have a router, they have a switch. Inside IDU, which you see indoor unit, you can see a, there is device, one device only is shown here. But in detail, if you Google what are the devices into the IDU of the Airtel tower or Geo tower, they will give you a list of devices that there are MUX available, multiplexers are there, and routers are there, switches are there. There are a lot of other devices, key devices are there. So there are a variety of devices. But we access, when you will become a network engineer, you guys or we guys will be sitting in the NOC. In the NOC, we access these all towers. In these towers, there are again base stations, there are again BSC, MSC. We won't go much more detail into that. But as a network engineer, when you sit in the NOC, you have to access those points. You have to access those BSC sometime, leaf points, and then MSC sometime. So these are interconnected again. And there are certain protocols that they are following. So we'll see BGP protocol there in the coming later section. Like when we go in little advance into the CCNA, we'll be looking into all those terminologies and everything. Meanwhile, just you can see in the right-hand side, you can see on the top, antenna is there. So they work on certain power. They radiate some power. So they have they are measured into dB. So they set that power in a certain limit that you can't radiate more than that. That's his RDS to help. And then there is a direction with which you align the antenna. So these are the just a generic term wherein first one is wrong, alignment is wrong, second alignment is again wrong, third one is the correct one. So that's how antenna is aligned, and then that is connected to a router. First of all, MUX. There are a lot of devices again. MUX, Ricky device, then MUX, and then router. So that's how the sequence goes. So now we are clear that okay, on this towers, the water towers we see, there are two kinds of devices which are hanging. RF device number one, say it with me, RF device number one. Number two, microwave device. So these are the two kind of devices which are hanging on this. 90% towers, these are the only two devices which they hang on these towers. And then they update technology on these devices only. These devices, earlier it was 4G, then now they are coming with 5G. So this device gets updated. Like we have our software version 1, version 2. So they have their 4G, 3G, 4G, 5G. So they update these devices. Sometimes they update their software. Sometimes they change the hardware if required. So that's how 3G, 4G is there. So 3G, 4G, 5G is nothing, just a update of device. And yep, definitely they have make a big market on that. Mobile companies, 5G, 5G, 5G. I mean, okay, 5G, but that's just a modification. They have two technologies ahead in their laboratories. They won't say us. They want to make money at certain point. Fine, that's enough for business for now. So fine, this is 3G, 4G, 5G, all hanging on a tower on these towers. What you see, and these two devices which update this 3G, 4G, 5G, what we see in our day-to-day life. So this is what it is. Nothing much big jargon. That's how these are the various towers which gets connected. And what these towers do, they facilitate the traffic between our home network and this data center. That's what these towers do. And how these towers achieve those things, there are two devices like RF devices and microwave devices, and on a certain frequency they do this. So guys, hope things are clear. I mean, things are making sense now. I'll take a little recap and try to figure it out that things are going clear to everyone. Everyone is getting the data. So summing it up, there are two things. I'll take it again. Endpoint one, that is we guys who are accessing. Like just a layman example, you are using Facebook. So we guys are sitting here. Endpoint two, this is Facebook data. Whatever our data we send, Facebook stores those data into this kind of data centers. That is endpoint two. And inside this data centers, this kind of architecture is there. Three, how we are connected with Facebook. This is how we are connected through this network, through this kind of towers. We are getting connected with the data centers. So there are three things which we saw. First, endpoint A, we users, endpoint two, data centers, and in between the traffic. So now we also know our utility, where we stand as a network engineer. So we can either get a job into data centers or we can go into any of these service providers. So going forward now, now we are going more deep, like we are going more specific to the networks. Like herein we saw IDUs. So these are indoor unit device. So we'll focus more into indoor unit. Because that's what our, we are focusing more CCNA we are doing here. We are focusing more into this routing and switching. There are again various streams of certification. One is for wireless, one is for data, and one is for routing and switching. So the best is one should start with RNS, then further they can, they can leverage themselves to wireless or wherever their interests take them. Like suppose you want to go for wireless, then these things are very helpful for RF and these all things. But as of now, we are going with routing and switching. So routing and switching finds its application both the ends, at end A, our home also, or any big company, or to the data centers also. So we find RNS find routing and switching finds its application everywhere. Very easy to get job, very handy. So that's the best thing we can do. So well, let's get started with routing and switching. That how it works, what are the devices. So we will see that what are the devices, starting with the routing and switching devices. So there are various components like router, switch, then there are NIC cards, connectors. NIC cards, when you plug your wire, nowadays we are using Wi-Fi, but in old days when we use computer, nowadays in computer also Wi-Fi facilities there, but we can use a RJ45 connector, and NIC card is there inside a computer. So we plug in our RJ45 connector into that. So this is how, there are other routing devices. We'll see in our next slide. So what are the types of networking devices? This is one of the questions which they ask. Like few of them are obsolete, like hub are no more used in the market. But when we come for certification exam, they can ask the definition. They can have a multiple choice questions, and a lot of things they can ask from this. So this slide is very important. We can get a lot of questions out of that, and we'll see what are those networking devices. So first one in the left hand corner, access point. AP is a device that sends and receives data wirelessly over a radio frequency. So That's like our router only. Our router can act as access point. So we can use our router as AP if we are using it in our home. Suppose that's the industry, then we will have like a RF device like this. They can work as a AP. So these are access points. Then there are bridge. Bridge is a networking bridge that acts as interconnecting between two LANs, creating a single network from separate LANs. So when we want to join two LANs, LAN means local area network. We will see again in future. We are just taking a bit summary of today, summary of everything we are taking. So we will see in detail upcoming days that what these LAN are, WAN are, MAN are. We'll see all these metropolitan area network, wide area network, and local area network. We'll see these in detail, but just for our basic understanding, we see LAN means local network. Like local network means suppose inside your house, we are all device connected with one router. So that is one network only. You go to another house, your neighbor house. Suppose I'm in house A. In house B, my neighbors residing there. They have another network. So that is another local area network. And these two local area network, your house and your neighbor house, they are getting connected with again with this tower, because with this tower, like I'm laptop at end A, they are at end other end. So they are getting connected with they have to flow the traffic pattern from this tower, and they have to come. So they are both at different LANs. So they both LAN getting connected with a WAN, wide area network. So two LANs you can connect two LANs, separate LANs with a wide area network. But when you have two local LANs and you don't use any tower, you don't want to use any tower. I say, oh, I don't want to go to service provider. I don't want to pay them. I want to connect with my neighbor, and I don't want to pay any money for that. So what I can do? Yeah, you can install a bridge. Nowadays, switches are there. Bridge no one uses. It's obsolete. But yeah, just to know, bridges connect to LANs. So LAN means two